So I'm Tessie Wilkerson. I'm with Mississippi State University in Stoneville, Mississippi at the Delta Research and Extension Center. Today I'm going to talk to you a little bit about a United Soybean Board project that I'm working on with a bunch of other collaborators, about 5 universities, and then the USDA as well. So why are we looking at this? So historically we've had problems in past years with seed quality. And farmers going to the elevators and getting extreme dockage for having bad seed just because they weren't able to get their stuff out of the field in a timely manner after it was matured. So back in 2017, Southern Soybean Disease Workers estimated that we had about 52,500 metric tons of grain lost over the 16 states. And then in 2018, we had a really tough fall trying to get stuff out of the field, and we saw that both in the northern and southern states, we lost about 87 million bushels to Phomopsis seed decay caused by Phomopsis diploidy complex. So what's the cause of this? Why is this happening? So we're seeing, why are we losing all this money? Because we're seeing a decline in seed quality before we're able to harvest. Plants are getting mature, rain is happening, fields are muddy, farmers can't get in the field to get their plants out, and it's sitting there. So when I'm talking about reduced seed quality, I'm talking about mold. Seeds can have Phomopsis, which would be chalky, misshapen, elongated seed, and this reduces your germination and vigor. This causes significant reductions at the elevator. And these are some prominent years that we've seen this occur: 2001, 2009, 2017, and 2018. One of the biggest deals of this is extremely environmentally dependent. So if you don't have the conditions in the fall, which is going to promote this type of issue, then you're not going to see it. So with that being said, if you look at the environment, in 2009, you can see that you see that is in the dark bars, lots of rain during the times that we would be harvesting in our areas. And then if you look at 2018, a very similar situation in August and September during harvest times, which was one of the main reasons why we saw this is such a big issue in 2018. I don't have the numbers for 2019 up there yet, but we did have significantly less amount of rainfall during the time that our growers were harvesting, so we did not see as much issue in 2019 with seed quality. So a group of us got together and said, well, we need to try to work on this. We need to try to figure out something to do to help farmers with this issue. So we constructed a team, University of Missouri, Dr. Chen, who is a soybean breeder, Dr. Pantalone, who's also a soybean breeder, Dr. Gillen and Smith, who's at the USDA in Stoneville, who are both soybean breeders and research geneticists. And Dr. Darren Mueller at Iowa State kind of wanted to get in on this too, since the North also had some issues with seed quality as well, since we originally kind of thought this might be something that we're seeing in the South. Dr. Way at Texas for the entomology aspect of it, and then Dr. Copes at LSU replacing Dr. Spivey. Okay, so we wanted to figure out, so how can we fix this, or what can we do to maybe lessen the problems associated with this? So we wanted to develop or test breeding lines exhibiting minimal mature seed damage. And then also determine, since there's a big talk about, well, what if we spray a fungicide later in the season? Will that help protect it, protect the seed when we get ready for harvest if it is delayed? So we wanted to test fungicide efficacy with seed damage. And then also Dr. Mueller at Iowa State said, well, what about the seed treatment aspect? I get a whole bunch of questions about, well, what if we put a seed treatment on it? Is that going to help when we start putting the seed back in the ground? And then also, how do we get this information out there to growers? How are we doing outreach and extension to make sure that they know what they need to be doing? So I'm going to start out with some stuff that I'm doing at Stoneville. One of my graduate students is working on this. This is her second year doing this, and I'm going to report on actually 2019. We did have some significance between the 2 years, so I didn't put them in there together. So we're going to show, and I actually added some stuff this year I'm not so sure she's excited about that, but it was a request from the board that we add some things, and so I'm going to talk to you about that. So what we have is at Stoneville we have these 2 shelters. Originally these were constructed to do seed quality work, and what they are is they're almost like a greenhouse type frame. They're equipped with overhead irrigation, and there's a certain percentage of visibility to kind of create that environment which you would have an overcast, cloudy type environment, and then the ability for us to make it rain whenever we want it to. So once those beans are mature, we can pour the rain on it to see how they respond. So this particular year, we didn't get this planted until July. We had some issues with one of the shelters. The plastic had come off, and the company that was going to fix those had a really busy season. So we didn't get these actually planted until July. So that was kind of unfortunate. But we had premier lines that we got from the USDA in Stoneville, Dr. Smith and Dr. Ann working on this, that they sent over, because they said these were part of their nursery were some premier lines that they saw reduced issues with seed quality. So we started these trials. We put in these 1-row plots, and we put them on 30s just to make sure that we were able to create that humid environment within there. And we inoculated these at R5 with Phomopsis just to make sure that we had that component in there. And then we irrigated in the shelters throughout the season. This year was approximately 82 hours after R5. So, and then we also did the same outside because there was a request of one of the members of the board that said, well, you know, we can create this, but what do these lines do if we have them outside these shelters in just a natural environment? We want to know what they do. So we put these 2 trials, the same ones on the outside, and the difference between 1 and 2 and 4 and 5 out here is one of these shelters has no fungicide applications whatsoever, and then the other shelter has a fungicide application late season to test that theory. Oh, well, what if we put a fungicide on later? Is that going to help us later on in the season? So then we took these to harvest approximately 2 weeks after they were mature. We let them stay out there so that they could get as much weathering and simulate that particular situation where a grower wouldn't be able to get in the field. And then, so I will mention this, that these were different maturity groups, and we did harvest most of these with a 1-row combine. However, some of the earlier maturities were mature before we could actually get in the field, so we actually had to hand harvest these, but they were harvested 2 weeks past the maturity that they were. So if they were a group 3, once they got done, obviously before the 4s, we had to get out there and harvest them. So after harvest, we took test weight using Mini-GAC 2500, which is gives you a reading that's pretty similar to what you're going to see when you take it to one of your grain services. We did plot weight in grams, which we will convert to bushels per acre, and then we took some damage ratings. And I will say, last year we did an overall visual rating, which was a subjective rating that we would do ourselves, and we also send these seed to Mid-South Grain. But this year I won't have that data just yet because they're still working on that stuff. So we will have that to be out there, but we just don't have it yet. Okay, so I'm going to go ahead and move into the results. So this was one of the shelters that had no fungicide whatsoever. On the x-axis you have the different lines, and y-axis you have your seed per plot in grams, and on the other side we have pounds per bushel for your test weight, and also your visual ratings of 0 to 10, 0 being no damage and 10 being unacceptable. So in the blue you'll have, and then also this red, there's your plot weights. The gray line will be your visual damage, and the orange line will be your test weight. And what we saw from this is pretty much test weight remained about the same, around an average of 55 or so. So we didn't see a whole lot of difference with that. We did see some differences in some of our PI lines within our plot weights. And these were actually, and I'm sorry I didn't mention, these were our commercial checks, CZ3841 being group 3, and the others being in group 4s. And what we did see that We saw some significant differences in damage. However, they were a little bit higher than we thought they would be, but we had a few that were around 3-ish. So there are some differences between these lines, and none of them are going to have a 0 with these, but there are some differences, so there is definitely some resistance within them. Now, if we look at the shelter that had the fungicide applied, once again, about the same scenario. The trend is that there we do see some different lines that are providing more yield. Really, a few more differences in test weight, but not many. And then a few differences in damage, but about like the others. So we don't really see that the fungicide is really providing any extra benefit. It's fairly similar. Okay, so if we move to the outside areas that have no shelter, that were exactly identical to the others under the shelters, we kind of see a reduction in plot weight, which was when it's outside. Now, I will say this, going back, all these trials were harvested in November. So, that's not typically when we harvest our trials. It's not typically when we plant our trials. So plot weights and things will be a little bit lower than we would think than they should be, just because of the timing of planting and harvest. And I do apologize for this. There were some plots that didn't have enough seed that we could take test weight. That little machine requires a certain amount of seed to be able to get those readings. But about the same situation with damage here. During this part of the season, we actually had more rain events in that time frame than we did before. We saw the damage, even though we weren't under the shelters, given it rain all the time, we still saw that damage. And pretty much the same. A few of them that have a little bit lower, a little significantly lower, but nothing, of course, like I said, is a 0. But there are promising lines out there. Okay, and for the fungicide applied one outside, no significance with the damage. We did see some significantly differences within plot weights, which was kind of curious. I was kind of curious that some of them seemed lower than the non-fungicide, which leads me to believe that maybe that fungicide is taking something out of there that's beneficial. So like when you spray, for an insect, you might take out a beneficial insect that would have helped you later on. Maybe you're taking something out of the environment that you need, but it's obviously not giving us any benefit just taking that spray on, as far as seed quality is concerned. Okay, so now I'm going to move on to one of the projects that the USDA is doing in their nursery there at Stoneville. They have a few other lines that they're working on that are actually, I think, new this year. And so I'm going to go ahead and set up this figure for you. So their lines are on the x-axis. On the y, you've got your seed yield in bushels per acre. And on the other side, you've got your losses calculated per 100 acres. So your black bars are going to be your yield commercials. And this particular line right here, which we had in my trials as well, is your Phomopsis check. It is a Phomopsis resistant line. And your yellow bars are going to be their new lines that they're looking at, that they're calling their breeding lines, which are higher yielding. So you have some 4 earlies and some 4 lates. And what you can see is with this this CZ 3841, which I also had in my trials, it has significantly higher damage, whereas, and then it's also as a check, Progeny 42 has lower damage, but it still has some, and also the commercial line, the Pioneer 46T39, also has damage, but these other lines that are also yielding better than some of the other ones that I showed you are pretty much at zeros for damage. So it looks like these would be promising for the future. And they do want me to mention that these lines are actually available, to anybody that wants to test with them. They just have to fill out some paperwork, some MTA, but they're out there for public release if anybody wants to use them to move forward. Okay, and so then another thing we were thinking about is, okay, so for the future, we have these lines that might move forward, but in the future, if we want to do more of this, where can we pull some more lines from? So Dr. Punyan at Missouri said, well, let's look at some plant introductions. Let's look at some different types of seed, some different types of plants to see if that particular seed maybe has something that would be, that we could use to introduce some resistance, some seed damage resistance. So basically we looked at some group 4s. I actually had some group 3s at my location too, but I'm only going to report on the 4s today. But you can see that they all look different. Some of them are black seed, green seed, the tan, and these are almost speckled. So what is it that they have? Do they maybe have something that we can move forward in the future to help with this issue? So we grew these out and harvested them when they were ready. And so at my location, I had 321 total plots, and we took those and we scored those all for damage visually. We also did germ, and some locations were able to do test weight. I wasn't able to do test weight, but we did germ, and I don't have the germ data. But what we found is that a lot of these lines were within the 0 to 2 range when you rated them visually for damage. So that means that they have a potential for breeding in the future. And then for Louisiana, did this same trial. They had 321, and they saw basically the same thing, although they had more around this 2 mark than we did. Could be, because of environment, etc. But so they also saw that there was a lot of potential for the future in this screening. And then Tennessee also did the same thing, where his scale was a little bit different. He uses 0 to 9 instead of 0 to 10, but it's primarily the same observation, is that we had a lot that were within the 1 to 2 range, so they were able to be used for breeding in the future if one wanted to do that. So for the breeding efforts, in summary, in 2017 and 2018, we had much more damage than 2019. We saw the susceptible checks still had damage, and that we did see some breeding lines that had minimal damage levels in 2019. And then also with my stuff, we saw that fungicide applications don't necessarily, or not with this data, don't provide any benefit with regards to seed damage. And then we also, screening these PIs, we found out that if we need it in the future, there are some germplasm out there that we can go back to provide some new lines. And now I'm going to move on to another part of this that Dr. Mueller did at Iowa State, where he was wanting to look at seed treatments and how that affects planting and such. So he looked at seed treatment selection, seed treatments, and planting population of high and low quality seed. And so he had 2 experiments, and basically he had a field where he harvested October 4th and October 17th. And he took these seed and he put them in 2 batches. He put 88% would be the high quality and 37% would be the low quality germination. For his treatments, he characterized a high and low quality seed. He had a treated versus a non-treated, and he had 2 planting populations, 125,000 and 175,000. For his experiment 2, he looked at the effect on seed quality on plant growth and yield. He had this in several states, and he also separated these seed into high quality and low quality seed, with 99% as his high quality and a 13% being termed as low quality for germination. And for these treatments, he had high and low quality seed at different populations, and then he also thinned these down. So looking at these results, so you're looking at your low quality, and then you're also your high quality. You have a base fungicide, and I don't have the actual ingredients of that base right now, but then he also tested with nothing for both of these. And if you see, you can tell that even with the base, that you did have an increase in field emergence and also a slight increase in yield. And even with the high seed quality, with and without the seed treatments, you saw an increase with the seed treatment on there. So basically, we're wanting to, you're not necessarily resurrecting a dead seed, but you're protecting the seed that you have by putting a fungicide on it or a seed treatment so that it can come up out of the ground and live, and produce yield at the end. So this would be the late planted trial, and we see a little bit more difference with the low quality seed in this particular trial, with the pretty low emergence here, but if you put that seed treatment on it, you've got an increase, and then also a slight increase in yield. But with the high quality, you don't really see that on this particular one with the later harvested, and actually a little bit of a decrease in yield with the high quality. So once again, you're just protecting what you have out there. If you have this situation, definitely a good idea to put a seed treatment on for other things for seedling diseases and things like that. And so for his experiment 2, where he was looking at planting population and the growth and yield, he didn't see any significant differences in his 2 planting populations or the low and high quality seed with regards to yield in this particular, across these 3 locations. So in summary on here, he did see that he had seed infected with diporthy in 2018, and the seed treatment increased field emergence for both low and high quality, just because it's protecting what you have out there. And seed treatment increased yield for the low quality. That's because you have more plants out there, not necessarily that it's doing anything within the plant. And that low seed quality does affect germination, because you have to have your stand out there, and once the stand established, there's no further issues. So you're protecting it to get it out of the ground, and then you're good. So for the last thing we were looking at is our outreach efforts to try to get this out there to the growers and to colleagues, so that the information can be dispersed. So we're doing a bunch of different things. Dr. Mueller's handling Crop Protection Network, and we also have, Mississippi State has the Crop Situation podcast that they do podcasts on these types of things. There was one on seed quality. Tom Allen did one on seed quality, I think, this past spring. And then we also have our blog, and then we're also training graduate students as well to provide, scientists for the future to continue on this type of work. So, we're getting closer. We've got lines that are coming out. The breeders have lines that are coming out that will be available in 2021, hopefully. And we kind of are getting a better understanding of why these things are happening, when you need to plant, when you need to harvest. If you're planting, a certain amount of soybeans, don't plant them all at one time so that you can get out there in the field when it is harvest time and harvest what's ready, and then you don't have to deal with these issues. And then also, we're updating our management suggestions and our extension publications to get that word out there. So I can't do this work without my funding sources, the USB, the Mid-South Board, and also the Mississippi Soybean Promotion Board. They've provided all the funding for this, and we really appreciate their support. I also have to give credit to my counterparts at the universities and USDA. They've done a tremendous amount of work on this, and then also my guys at Stoneville, student workers and grad students and support staff. And with that, I'll take any questions.
How do we access the Mississippi State on the computer, the information? I'm a grower. And how do we access that?
It's going to be, for the blog, it's going to be MS State, it's going to be MS Crops Situation blog. Situation.com, I think is what it is. MS Crops Situation, and it should pull it up for you.
Thank you, ma'am.
Mm-hmm.
If I wanted to, how would I go about joining your team?
Just talk to me.
We've been doing a lot of work on seed quality with his test weights, and we even started a GWISE with
Okay.
we're looking at group 5
Okay.
instead of 4.
Okay.
And so I think some of the things that we're doing would fit in nicely with what you're looking at.
Okay. Yeah. So we've put in a pre-proposal for this coming year. But I'm sure we can get you added to that.
Yeah.
So yeah.
And one more thing.
Okay.
You said that it looked, y'all in your studies, it looked like the seed treatments really affected yield, but that's only on the low quality seed. It didn't help any of the high quality seed. When you compare that with the cost of putting seed treatments on, what's your feeling on that, if it's worth it?
No, well, the thing is a seed treatment is there to help you to get out of the ground. So, you know, you may not be in a situation where there may be something that's going to prevent that, but if you are, that's your protection. So I wouldn't recommend or suggest going without that seed treatment in our area. That's it.